All right, so I said I was going to talk to you about another way that you can do these problems, and really, this is the method that I choose, and I highly recommend that if you're going to um, pre-calculus, that you give this a shot to try to work through this because it is a mathematical process. But again, what we are doing here is trying to find two binomials that I can write out that would multiply together to equal this. So what I do here is I ask myself, what two numbers can multiply to 2x squared? What could be 2x? An X, right? And then now I go through all of the numbers of 12. So I wouldn't write this on my paper, but it's 1 and 12, 2 and 6, and 3 and 4. And I'm trying to put those in here to when I multiply the outside time and plus the inside, it adds up to 11. So all the numbers that multiply to 12 are here. So again, I'm going to make a mistake here and show you something that doesn't work. I'm going to put a 6 here and a 2 here. And when I do that, okay, yes, 2 times 6 is 12. That's what multiplies to my last term. But when I do the outer plus the inner, okay, 2 times 6 is 12. 2 times 1 is 2. That would equal 14. This would have to be a 14 for this to be right. So I'm putting all of the numbers here, and it matters what you put here. Okay. So I know that I'm multiplying this by 2. So again, if I have what two numbers, if I put a 4 here and a 3 here, look, 2x times 4 is 8, and 3 times x is 3. This 8x plus 3x gives me my middle term. So again, if you really understand numbers and you can kind of do foiling in your head, then this to me is the easier method. Um, to do this. This is the factored form. I was looking for the numbers that multiply to 2x squared. Well, that was 2x and x, and numbers that multiply to 12. And I was testing them. I was checking them to see what worked. So again, if I was doing this problem, now here's where they get a little bit difficult. It could be a 4x and an x, or it could be a 2x and a 2x. I don't know which one it is until I try all of these different numbers and combinations. I know that the only numbers that multiply to -3 are -3 and 1. So again, as I put these in here, I've got to try and find that combination to when I add those, it would add up to 4. Okay. So looking at this, I know that this multiplies to 4x squared. So I'm looking for -3. Okay, numbers that multiply to -3. So it's going to be a -3 and a 1. Okay, and it's got to add to -4. So if I put a -3 here and a +1 here, my outside is a 2x, my inner is a -6x, and that equals a -4x when I add them. So again, I'm putting only numbers at the beginning that multiply to my first term, and I'm only putting numbers at the end that multiply to my last term, and then I'm checking the outer plus the inner as to whether or not that adds up to my middle term. So this is useless. That doesn't work, but this right here would work. Okay, so here I have a 7x and an x. Those are the only two numbers that multiply to 7x. Now, the only two numbers that multiply to 7 are 7 and 1, but I have to put them in here so that when I do the outer plus the inner, my outer plus my inner has to add up to 50. Okay, again, it's just a quicker method, a little bit cleaner. Um, again, 2x and 2x, or it might be 4x an X. I don't know. I gotta check it. Okay, I'm getting doing my numbers that multiply to -15. So I know 5 and 3 work. Okay, so 2 times 5 would be 10. 3 times 2 is 6. There it is. So it's going to be a +5 and a -3. Notice -3 times 5 is -15. When I check the outer, that would give me a 10x. When I check the inner, that gives me a -6x. And again, it's just another method for you to try this. The AC method always works. It just is a little bit more work. So that's just what I call the guess and check. Um, you can give it a shot, especially if you're planning to go to pre-calc. The number sense should be there.